Hey, hello everyone. Thank you all for coming. Everybody's still awake? Alright, so my name is Wim Meeussen and I lead the developer engineering team for APAC in Google. And it's amazing to see so many local developers here in the building. I moved to APAC myself just a few months ago. I used to be based in California, and I moved here to build out an engineering presence so we can really support you guys for AR and VR locally in the region. So let me start up the slide deck here. So today, I want to talk about mobile AR and mobile VR. And maybe first, let's ask the question, why does Google care so much about AR and VR? Why do we want to invest so much in AR and VR? Because Google's mission is not about putting a VR headset on everybody's face. We're all about making information accessible, making information useful. So why do we do AR? And here, because we really believe AR and VR are the next big compute platforms that's coming up. So you all, if you look at kind of the history of computing platforms, every 15 years or so, we see a major kind of quantum leap in functionality. We started out with mainframes where only people wearing long white lab coats would operate computers. We went to personal computing, internet, and you also kind of the mobile space happened very quickly. And we believe the next big kind of way for people to interact with information is going to be AR and VR. And to interact with information, VR can teleport you from wherever you are into a new virtual world. You can really immerse yourself with new information. You can see worlds real worlds, imaginary worlds. And with AR, you can think about you starting to augment the real world. You enhance the real world, you show additional information about the real world. So both AR and VR are really powerful new ways to interact with information. So this is obviously why Google cares a lot. But then, okay, so we care a lot about AR and VR, but why do we build AR and VR on mobile devices? And the answer is pretty simple. Mobile is where scale is. There's 3 billion mobile phones out in the world today. And every year there's 1.5 billion new phones that are getting purchased. So if you want to do anything at scale in AR and VR today, you have to leverage mobile. So that's why we really built on mobile AR and VR. So today I'll talk about Daydream, which is our mobile VR platform. And I'll talk about Tango, which is our mobile AR platform. And the cool thing is, for both Daydream and Tango, they exist today. There's devices that you can go buy today. So this is not a story about something you can do in the future. This is all possible right now, today. And there's 2 things I would really like you to take away from this talk. There's one for AR and one for VR. For VR, I want you to learn, as a developer, what are the key building blocks that allow you to create this real sense of immersion? To get a sense of, you being present somewhere else. And then for AR, I would want you to come away with, what are the building blocks as a developer to make virtual objects look real in AR? So if those are the only 2 things you remember from today, I would be very happy. That would be spectacular. So let's get started with Daydream. By raise of hands, who in the audience has experienced VR before? I see about a third of the hands go up. Who has experienced Daydream before? Oh, that is very few hands. So okay, I think it's good. I feel useful to talk about Daydream today. So here you can kind of see Daydream in the lineup of kind of what exists in VR. On like the left-hand side, you have cardboard, which is kind of the true success story of democratizing VR. Like cardboard is very, very cheap, very affordable. We have sold 10 million cardboards as of today. On the whole other end of the spectrum, you have kind of the high-end, high-quality desktop VR. And Daydream falls somewhere in the middle between those two. And you can see both Cardboard and Daydream are built on mobile, because again, that's where we believe scale is. And for you as a developer, scale matters. Like if you want to make a living, you need to have a platform with scale. So let's take a little look at what Daydream looks like. So there's three components. There's the phone, the Daydream viewer, and then the Daydream controller. And we have designed all these three components to work together seamlessly, to create like a real great VR experience. So if you look at the phones, we started out with the Google Pixel, like as a first Daydream-ready phone. But if we really want to achieve scale, like it cannot stop there. So Google has been partnering with a lot of OEMs to build more and more Daydream-ready phones. So there's Motorola, ZTE, those are already for sale today. And both Asus and Huawei are building new Daydream-ready phones that are coming out soon. So there's a whole ecosystem of Daydream-ready phones that are coming out. So now let's take a look at the Daydream viewer. So we really wanted it to be simple, easy, there's like no buttons, no cables, no wires. Like it had to be very easy to get into and out of VR. So to get into VR, all you do is you unlatch the viewer, you pop in your phone, and you latch. That's it. The viewer and the phone will automatically communicate with each other and put the phone in VR mode. And then the phone will also automatically align itself with the viewer. So then there is a Daydream controller. So again, we wanted to make it really, really simple. Because think about it, if you're in VR, you're basically using the controller blindfolded. Like you can't see the buttons. So it has to be very simple. So the Daydream controller comes with a touchpad, so that's going to be most of your interaction. And then we have two other buttons. One button that you can use as a developer, and then a home button that will just always bring you back into the main Daydream home menu. So let's put on the viewer and kind of let's see what it means to jump into VR as a user. So the first thing you always get to see is what we call Daydream Home. So this is kind of your central place from where you can start up apps, you can go to the Play Store, you can buy apps, you can watch videos. You can always come back here and start again without ever having to leave VR to switch between applications. And I have a short video kind of showing all the different apps that today already have been created on top of Daydream. So let's play that. We're missing some sound. There we go. So lots of really cool applications that are already launched for Daydream today. So this was kind of the consumer point of view for Daydream. You've probably seen some of that, online. Let's now take a look at the developer perspective. So, what does it mean to create VR? So, essentially what you're trying to do is you want to trick your brain into believing you're somewhere where you're not. Like you want to create this illusion for your brain. And in order to create that illusion, there's three components that are really important. And these are the three things that I want you to remember today. So to create real immersive feel in VR, you need to think about what you see, what you hear, and then how you interact with the world. So those three components all together kind of are able to trick your brain into that immersive feeling. So let's look at all three of them in more detail. So first, think about what you're seeing. Like, the most important thing for VR is like how your motion relates to what you see. So in the real world, if I move, my inner ear will feel this motion, and then instantaneously my eye will see new light coming, and this motion to the result of that motion is almost instantaneously. Now if you want to simulate this in VR, there's a lot that needs to happen between that motion and seeing the result of the motion. So first, after you move, some sensor needs to pick up that motion. Then that signal needs to get processed into some kind of motion model. Based on where you think you are, you need to then start rendering a new frame. That frame needs to get sent to the display, and then finally your eye can see the result. So there's all these steps between motion and photon. And what we learned in order to get really great VR, that delay, that latency, has to be below 20 milliseconds. So this is really critical for VR. If you're not below those 20 milliseconds, then you cannot create that illusion for your brain that it's actually real. So to make Daydream hit these 20 milliseconds, we had to do two things. Like one, we had to specially design the hardware to be Daydream ready. So what this means is we have low persistence displays, so we can render very quickly, get new content online. We also need to have very power-exposed chips to process all the frames to be rendered. And then obviously, third, you want to have very accurate, low latency sensors to sense that motion. So only some phones can be Daydream ready because we have these high specs in order to meet those 20 milliseconds. Then on the software side, we also had to make a number of changes. So in Android N, we designed it to be fully Daydream and fully VR ready. So what does it mean? Like Android N is able to give a sustained performance. So what you don't want in VR is that you have a peak performance, and then your phone gets too hot, and then it throttles down and goes back up. That makes for very bad VR. So you want a steady, sustained performance. Android N also has head tracking built in. So you can know how your user is moving. And then the system UI in Android N is designed so you can stay in VR even when a notification comes in, or when a phone call comes in, or maybe you want to make an in-app purchase. You always want to stay in VR. You don't want to take off and on your viewer all the time. And then obviously, Android N has been designed to be very, very low latency. All the leaves in great detail, have lots of polygons. Maybe the leaves can move in the wind. But it's going to be very, very difficult on mobile. What you could do instead is you can have a very, very low polygon tree. If you add audio on top of that, so let's say you hear the wind blow through the leaves, you can actually create the same or even better immersion for the user than when you spend all your effort on crazy rendering. So when you're designing for VR, think about this. You don't have to spend all your energy on rendering. Think about audio as an alternative that gives you, the ability to have immersion without all the crazy graphics. And obviously, sound is not the same everywhere. When you and I are having a conversation in the forest, it'll sound very different from when we're having that same conversation in a spaceship. So the Daydream VR SDK has built-in support for kind of different audio scenes. So you can just select in what kind of a space that you are, and the audio will automatically get rendered for you. And then, for VR, start thinking about audio as more than left and right stereo. Think about audio as something that's all around you. Like in VR, you can hear sounds behind you, and it's very, very powerful as a user to really be immersed in audio. Alright, so we talked about what you see, what you hear. The third part is interaction. Like in the real world, you can interact with things, so in VR, you should also be able to interact with the world. So you saw the Daydream controller already. So we talked a little bit about the buttons. But the other cool part is the Daydream controller has built-in sensors to kind of sense its own orientation. And if you only sense orientation, that sounds not very powerful. But what we did is, we combined that with the knowledge of the mechanics of your arm. So the sensors in the controller combined with like how your arm moves and how your head moves actually results in a very, very expressive interface. In the simplest form, you can see it as like a laser pointer that you can use to point places. But then there's all these other things you can do with your Daydream controller. You can use it as a golf club. You can use it to teleport yourself different places. And we experimented with like all these different ways of how you can use a Daydream controller. This is what we call our controller playground. So these are all open source examples of things you can do with a Daydream controller. Like you can flip pancakes, you can throw things. Like the possibilities are really, they're very, very, very large. So when you think about using the controller, think much further than just a laser pointer. Like try to be creative and like integrate the controller deep into your game. Alright, so these were the three main things. So when you design for VR, think about all three components. Don't try to focus too much on just one or the other. So now I have a few kind of best practices for a developer and like when you're creating something in VR. First thing, like when you imagine your user, think about your user sitting right there. Like a user in VR, you're somewhere comfortable, you can probably stay in VR for half an hour, maybe more. And think about if you're sitting there, you can look around you, but it's probably difficult to look all the way behind you. So imagine your user like right there, comfortably in that chair. That's a great mental model. And then motion is a bit of a tricky thing. Because with VR, we are simulating a different world. So if in the real world you're sitting down, and in VR you're sitting down, that's great. They're perfectly compatible. But if in VR you're moving, but in the real world you're still sitting down, that's kind of an incompatible signal for your brain. So if you want to use motion in VR, like if you want your user to walk around in VR, try to be very careful with that. Like, try to have slow motion. And if you want some very intense action, keep it very short. Because in real life, your user is sitting still, so you don't want that kind of incompatibility between VR and the real world for too long. And now I have kind of a series of funny pictures. The basic message there is, if something is scary or uncomfortable in the real world, it's also going to be scary and uncomfortable in VR. So if you're afraid of heights in the real world, you're going to be afraid of heights in the virtual world. It's not fun to be inside a table. You can feel claustrophobic in VR. VR can be so realistic, so you can really trigger those very basic emotions, so be careful with that. It can be scary to be in a really big open space. Pointy things can be very scary. And of course, it's not fun to get crushed in VR. So just keep in mind, VR is very, very real to our users. So think about the kind of things that you do. All right, that was VR. Are you guys still awake? Who is still awake? Anyone? I see hands, all right. So let's shift gears and go from VR to AR. And I promise I have some cool demos ready, so I'll be able to show some things. Who has heard about Tango before? I see a few hands. Great. So if VR was all about kind of creating this illusion for your brain, AR is all about allowing your device to understand the real world. And I'll explain a lot more like why and how, but that's kind of the biggest mental model. Like in AR, your phone needs to understand the world. And you and I, we're really great like, by just looking at a scene. We can recognize like the things in the scene. You recognize a couch, you know how you can walk around the couch. If you look at this scene, you know where there's a surface where you could put a glass, you know where there's sharp corners. You also can recognize situations that can be scary or that can be dangerous. So, based on visual input alone, like, we are really great at recognizing what that means. And with Tango, we want to give your phone that same ability to really recognize and understand the world. So instead of seeing this image as like millions of pixels, your Tango phone can really understand the geometry of that space. So Tango can understand like, what this space looks like, and it knows how it can move through space. And I'll explain a little bit why this is so important. But first, I'll talk a little bit about how we do that. Like, how can Tango understand the world? So this is an image kind of broken out of the first Tango-enabled phone that was released last November by Lenovo. And every Tango phone has three kind of unique hardware pieces. No more slides for you guys. Let me see if I can fix this here. There we go. Three unique pieces of hardware on every Tango phone. So the first one, every Tango phone comes with an active depth sensor. So typically there can be an infrared, either time of flight or triangulation sensor. But this allows your phone to see in 3D in the world. Second, every Tango phone has a motion tracking camera. And this allows your phone to see how it moves through space. And then, obviously, Tango does a lot of heavy visual processing, a lot of computer vision. So we need a special vision processing unit, like a special chip, to kind of crunch all those frames of visual information. So this is kind of what's unique about every Tango phone in the world. And if you kind of think about how phones kind of have changed over time, like the first mobile phones were all about just making a call. But then over time, more and more sensors get added. Think about cameras got added, accelerometers, gyros, GPS is now part of every phone. More recently, there's fingerprint sensors. And for Tango, we believe that that ability of your phone to see the world in the same way that we do is so fundamental that the Tango hardware will be kind of the next step in what's standard on every phone. So right now, late last year, Lenovo launched the Fab 2 Pro. So this was a worldwide launch, so this phone is for sale today. And then Asus announced their other phone that's also Tango enabled. The really cool thing about the Asus phone is that it can do both Tango and Daydream. So it's the first phone where one piece of hardware can do AR and VR. So this is really cool. So we talked about the hardware. Let's think a little bit about the software building blocks that you get on Tango as a developer. There's 3 blocks: motion tracking, depth perception, and area learning. So it's all relatively straightforward. So motion tracking just tells you like, how is your device moving through space? So if I start here with my phone and I move a few steps forward, motion tracking will just tell me, you moved 1 meter forward. And if I turn, motion tracking will tell me that I turned. So it's a centimeter level accuracy motion in 6 degrees of freedom. That perception is directly what you get from the Tango depth sensor. So if I point my phone at, for example, this table, my phone will see the 3D geometry of everything at the front of the table. So it's a direct way to get a 3D point cloud from your Tango phone. And then the last one, area learning. So I would like to do a little experiment with you guys to really explain area learning. So if I could ask everyone, can you close your eyes? Right, everybody has their eyes closed? Alright, now while keeping your eyes closed, I want you to point with your finger to the door where you came into this building. Alright, I see a ton of fingers pointing. Yeah, you can open your eyes again. So, the point I wanted to illustrate is that every one of you, when you came into this room, you started building up a memory of what this space looks like. And Tango with area learning does exactly the same. Tango can remember where it has been. So, now, I talked about how your phone needs to understand the world. And then we talked about how the hardware and the software supports understanding the world. But then maybe the basic question is, why do you need to understand the world to do AR? Like, let's say you want to render a really cool car in AR. Why do you need to understand the world? So, I have a whole set of demos ready to kind of illustrate that point. So if you could switch the projector to the phone here. So the setup I have here is a Lenovo Factory Pro phone, and then kind of a janky GoPro filming the phone. This is the easiest way to allow you guys to see what I'm seeing. Alright, so let's start very, very basic. And could we get some more light here in the background? This is, some form of AR. I have a virtual cat, and you can see the real world behind it. It's not very cool. This is kind of to illustrate a point of like how we will need to kind of build up to real VR, to real AR. So let's make our cat a little more clever. So instead of always rendering the cat right in the middle of the screen, I want it, if I move, I want to see the cat from different angles. So we start on the next step. Here's my cat. And this looks a lot like what you know from Pokemon Go. Like you have a little character, I can rotate, and it will kind of, move around with rotations. The really cool thing that Tango also offers, I can not only rotate, I can also move. I can walk up to my cat. And I can, go see my cat from different angles. So, number one, to do AR, you want your phone to know how it moves through the real world. Because if you know how your phone moves, you can render your cat correctly from all different angles. It's obviously not a really good demo yet, so let's take another step. So instead of having a flying cat, it's actually really cool if your cat, sits on the floor. Like real objects in the world, they feel gravity and they will end up on some plane. So in order to do good AR, your phone needs to understand, where is gravity going and where are the surfaces in the world. And because we understand where surfaces are, let's see if we can make the cat jump onto the table here. If I click onto the table, there we go. I always like to take a little picture. Could we try to get some light on the audience so you can take a group photo with the VR cat? With the AR cat. There we go. Alright, everybody hands up in the air? Alright, great, thanks. It's my souvenir from the talk today. So, we have our cat now behaving a little better, but let me show you some problems with this. So I'm going to position the cat behind here. And now look what happens if I go on the other side of the table. I can see the cat through the table. That's not very awesome. So, if you want your AR objects to be real, you also need to understand the geometry of obstacles. So let me try the last demo here. And now I'm going to use the Tango depth sensor to try to build up a basic mesh of what this obstacle looks like. So I'm building up a very basic model of a table. So now, let's put our cat back behind the table. So now if I move the other side of the table, I can hide my cat. And I guess here I'm showing it half transparent so you can see where we're hiding it. Here's the cat fully rendered, and here we're hiding the cat. So understanding obstacles is really important to create this realistic AR. And obviously if you build your app, don't make your cat translucent, like completely hide it. Alright, let's jump back to the slides. So three major things here, and I lost my earpiece. Three major things here to remember. So we started out with a cat like this. One, you want to have motion to render it from the correct angles. Number two, you want your cat to be on a surface, you want it to feel gravity. And then the last one, your cat needs to behave like real objects and be hidden behind obstacles. So those are the three main components that, if you apply those, you can actually generate very realistic AR. So there's obviously a lot more that you can do to create AR. If you look at the first car here, on the roof of the car you can see a reflection of the real building in the background. So there's a lot of extra things you can do to create really great AR. But just having motion, gravity, and occlusions, they get you a long, long way in making this realistic. Let's think about a number of use cases. Like, where have we seen people use Tango to build cool experiences? This is my personal favorite. This is my desk at work. And with Tango, I can see what it would be like to have a barbecue next to my desk. And this is obviously, a silly example, but the ability to kind of see virtual furniture or your barbecue or a couch, just to be able to see that in the real world is like a very powerful way to do shopping. Instead of having to look at a picture for online shopping, you can just place the object in your own house and see what it will look like. Here's an example of an app that Gap built to kind of check out what clothes would look like. So you get this AR mannequin that you can shape, to be roughly the size of yourself. You can fit it with virtual clothes, and then with Tango you can walk around and go check it out, how it looks from all different angles. So really, powerful retail applications. In education, like this is just a rendering, but think about the cool things you can do. Instead of kids reading in a book about what things are like, you can have them, see something in AR right in front of them. Then there's all, you can imagine from there, in automotive, you can all kind of try to see the things that you don't usually get to see. Here, one of my favorite applications, because Tango has a depth sensor built in, I can just walk around and start tapping on different corners of the table and get real physical dimensions. This was great because I just moved, like I said before, and I was looking for new apartments. I took Tango with me, and when I wanted to check out in the room to see if my bed was going to fit, I just used Tango as a super high-tech future way to measure my room. And it's so easy, so accessible, like it's your tape measure replacement. You can also start building full 3D models with Tango. Like using the depth sensor, the color camera, you can start creating these 3D meshes of what the world looks like. And this is pretty exciting. So you all know now what aerial learning is. So imagine if you're not just learning one room, but what if you build up a memory of an entire building, of every floor in a different building? If you have that memory, you can know exactly at centimeter level where you are in that building. And here are some of the cool things that you can do. So this video is something that exists in the real world. So this is the Detroit Institute of Arts. And with Tango, you're looking at a mummy, and in AR, you can start overlaying an X-ray scan of that mummy on top of it. And because Tango knows exactly where it is in the world, it can place that skeleton exactly in the right place. Another example of this, in the Art Science Museum in Singapore, we created a publicly visible experience where the whole museum area turns into an AR forest. So it's a very powerful experience where you can walk around and explore without being tethered to anything. So these are kind of the types of applications you can enable with Tango. So I hope you have kind of an idea of what you can do in VR, what you can do in AR. Then maybe to get back to the two things I wanted you to remember from today. So how do you create this sense of immersion in VR? Eyes, ears, hands. And then for AR, how do you make something look really real? Think about motion, gravity, occlusions. So if all you remember from today, this is spectacular. So before I go, here's the websites for both the developed platforms for AR and VR. Go check it out, and I'm excited to see what you guys are going to build. Right? Thank you.